Hey everyone, Shawn here from the Automation Blog and School, and this week on the Automation Podcast, I welcome back RC Crosby from P&F, who's going to bring us up to speed on RFID technology and products. RC, thank you for coming back on the Automation Podcast. I'm really looking forward to your presentation today on RFID. But before we go into that, I know some of the viewers and listeners will not have caught our first podcast together. So if you could you start off your presentation by just talking a little bit about yourself?
Sure. First, Shawn, thanks for having me. I'm excited to be here. Just a little bit about me. My name's RC Crosby. I'm down here in Texas. What I would consider myself an industrial automation generalist and a functional safeguarding specialist. I've been doing industrial automation for about 20 years now. Safeguarding for 10 years, and the last 7 or so with Pepperl+Fuchs. For those of you who don't know who Pepperl+Fuchs is, we're a privately held industrial automation company. Been in the business over 70 years, over 6,000 employees worldwide, 50,000 products in our portfolio. Kind of the two big claim to fame that we have is we invented the inductive proximity sensor. And we also invented the intrinsically safe circuit. Now, some of your listeners may be familiar with us, not necessarily from factory automation. We do have a division that does process automation, things like HMIs and purge and pressurization and things like that. If you have some questions on that, you can feel free to reach out to me my contact information will be available at the end of the presentation, but I'll get you pointed in the right direction. Our standard portfolio, in general, we have a great set line of sensing products, photoelectrics, ultrasonics, encoders, LiDAR, all the connectivity you need to put those pieces into your system. We also do positioning systems and identification systems, barcode, and RFID, which we'll talk about in just a second. We have a line of network communication products. Historically, P&F has lived outside of the cabinet. Now we have things that go inside the cabinet, such as managed and unmanaged network switches, serial gateways, which do protocol exchange from like serial to Ethernet IP protocols, Ethernet modules, edge gateway computers, things that really help take these intelligent products and put them on the network or into the cloud. Of course, being the functional safeguarding guy, I have to highlight the safeguarding portfolio. I have over 700 safety items that are SIL and PL assessed. Light curtains, safety switches, positioning systems, encoders, and the world's only safe ultrasonic sensor. But today we're talking about RFID. And I know what you're thinking. Why are we talking about a legacy product? It's been on the market for decades now. Yeah, we know what RFID is. But I think we've seen this shift over the last 18 to 24 months that kind of really none of us really saw coming 3 years ago. We've had some new market forces sort of kind of penetrate our ethos here, and COVID was a big one, and of course we've done e-commerce for years and years and years now, but COVID really kind of pushed e-commerce to the top. It's kind of the way we had to do things for a while. And the result was there was this great investment in material handling. Kind of part and parcel to that too is we've had these great staffing issues over the last 18 months. Again, with COVID, nobody really knew who was going to be available for the factory floor, kind of on a day in and day out or hourly basis in some cases, if you were kind of a part of somebody else's contact tracing. And then once we kind of got a handle on that, then we saw this wave of resignation, right? We call that the great resignation. It's kind of the way it's been dubbed. And kind of those two the entities have sort of forced this great importance on intelligent machine design. Um, because the landscape had changed, right? So either you automate the process or make the process completely autonomous so that either there is no worker required or there can be a worker, but I only need limited training for them to be able to monitor the system. So they really, should somebody leave or somebody not be available to work that day, the system can almost self-run, and I can train somebody quickly to get back on the system and monitor it. So some of the terms for that these days being thrown around are, obviously autonomous or lean production, lean facility, but all of these things, whether however you want to call it or not, require checks on the system, and that's where RFID resides, right? That's why we're talking about this today. It just makes sense. If you're going to create these intelligent machines, something has to monitor to make sure that these things are working correctly. And of course, it's still an advancing technology. It's still a technology, RFID, that Pepperl+Fuchs and our competitors are still investing in. People are still putting money into this, looking for explosive and incremental innovations into this product line. Shawn, did you have a question?
I was going to say, it kind of reminds me of like how we used to have a lot of toll workers
Mm-hmm.
on the Mass Pike and the New York Thruway. And, over time, I mean, we had the easy passes for a very long time. But at one point, people decided, hey, we don't need to have toll workers anymore. We can automate this using current generation or even last generation technology. We can just implement it in this application. And I know my son was telling me this last night. As he was driving down south, he's like, he was able to go through a lot of the easy pass lanes because they just take a picture of your license plate and send you, the toll bill. And so, it's using current technology or even some existing kind of legacy technology in a new application to become more efficient. And, sadly, in that case, the toll workers lost their jobs, but it really speeds up when you're going down the highway now, not having that long line of people in front of the toll. And I think when I think of RFID being now used in so many different places where it could have always been used, but wasn't, I think people are starting to think outside of the box, whether they're retrofitting a line for less people because they can't find people, which we know is a problem, or they're building a new line because they want to diversify where they're manufacturing their products, not putting all their eggs in one basket in case that basket has to go on lockdown. I think people are thinking, it's time to take a fresh new look at this to try to be more efficient, kind of like they did with the tolls, years ago. So that was just coming to my mind. It's like we're taking these existing technologies and we're using them in new applications, which maybe before it wasn't worth it because, it was, very inexpensive to get somebody in college to come work at your plant, full time during the summer, but now that's not an option. So just throwing that out there.
No, you're right. No, you're right. And just talking about the kids, I mean, my kids want to be TikTok influencers. They don't want to go to work for a factory. Yeah, so I get it.
And our people are much higher educated today with technology, right? If you go back to when I was a teenager, I was like one out of 100 people who were using computers, who had a home computer and was programming, right? Today, almost everybody has a home computer, and even those have kind of been replaced with tablets, and in some cases, smartphones. So we have a very technology-based populace now, right? Even our retirees are very techno, most of them are tech know-how. So they realize that, hey, we're in the 21st century. These piece part jobs, they're legacy jobs. And while I know they brought many people an income for many years, you know, it's time to get into the 21st century. Just like you wouldn't buy a car that has the manual window roll, handle that you have to roll it down yourself. No, I don't think any cars have that today. If they do, I don't know who would have that. Everybody expects power windows these days. So I think that's the same thing too.
But you're right, and although I can't take credit for this analogy, I'll give it. Automation, we don't automate jobs. We automate tasks, right? So the task of taking toll money was automated. I think back to the early '80s, right? When we first got ATMs at the bank, you know, we automated the task of the teller giving out money. We still have bank tellers even today, but that was the task that was automated, was the exchange of money. Now today you can deposit checks and deposit cash at the ATM, and all that's a little bit different, but we still have tellers, and there's still a need for bank workers. There's still a need for tollway workers that just may not be in taking money. There's somebody still has to maintain all those systems and whatnot. But so, yeah, you're right. Automation, it's not some scary thing out there to take people's jobs, but it is a thing that it's just a reality in our life. It just is. And we'll have to sort of wrap our arms around it, or those who don't are going to be sort of incorporated by those who do.
Yeah, totally.
So, what is RFID? It's radio frequency identification. Some really nice things is that since it is a radio field, does not need line of sight, and they're all open standards. So, we're all playing with the same level playing field. There are two main types, active and passive. Active, more or less microwave frequency. They require your tags to have a battery. They get a little bit longer range, but the trade-off is batteries die, and you can't recharge, in most cases, those batteries. So once they die, your tag is trash. The other type is passive, and that does not require a battery. It takes energy from the read head, excites the antenna to return the data. There are three main passive frequency ranges. You have the low frequency, which is right around 125 kilohertz. That's kind of like your badge scanner to get into a building. It's nearly tactile in range, very, very short range. You have high frequency, which is in that 13.56 megahertz range. You get about a foot of range with that. And now we have, for the better part of the last decade, ultra high frequency, which is in that 865 to 928 megahertz range. That you can get a couple meters of range based on antenna size and power being pushed to the antenna through the read head. One thing I will highlight is the low frequency and high frequency have a much tighter field, as you can see here. They're not as susceptible to atmospheric interference as, say, the ultra high frequency is. So you can see the ultra high frequency has greater read range here in this picture, but it's a little less organized than the low frequency, high frequency. So if ultra high frequency is something that you're considering for your application, I would definitely recommend a test. It is still a very, very good technology and can read, again, meters worth of distance, but again, it's not as organized as a low frequency, high frequency sort of field. There's only a handful of components that you really need. Obviously, you need your tag. You need a read-write head. In some cases, you need a controller that basically just takes the data being collected from the read-write head and give it to your PLC or industrial PC, and then cabling and software. So in some cases, you can fine-tune your RFID system using software. Many controllers have a built-in web page, or you can, many of the RFID manufacturers have a control software that usually comes with the device. So RFID historically has resided on the industrial Ethernet network, reporting to the PLC. However, it is also available in IO-Link, the point-to-point communications protocol. And what that gives you now is the ability to sort of divorce the data from the PLC, take it directly to an edge gateway, and straight into the cloud. I mean, PLCs are great for I/O control, not necessarily great for actual data processing. So we can take that now, really using the IO-Link point-to-point communications protocol, and move that into the cloud, do it somewhere else. So what do you use RFID for? This is pretty straightforward. Use it for access, so restricting and logging access to a system, and that gives accountability. We know who and when somebody accessed the system. We talked about checks on the system. We call that verification, right? Making sure that the correct parts are in the correct workflow process. And also we can use it for asset tracking, tracking vehicles through the WIP process or in and out of inventory, those types of things. So like you said earlier, obviously the imagination is the limit as far as what you can do with RFID, but some of your historic, more common ones are, access control, again, badge scanning, or in and out of a building, in and out of a parking structure, as you see here. AGVs for guidance and control. You have machine access, as I just alluded to. Material handling for tote verification, part verification. You have tool verification for these automated processes, things like CNC machines, routers that, if had the wrong head, could destroy the part, could destroy the substrate being routed, could destroy, thousands of dollars of damage to a CNC or a router head, if they were to strike something. So yeah, definitely powerful tool for that. Again, automotive, tracking vehicles through the assembly process, Kanban, pharmaceutical verification, hose verification for the process industries. And you put the wrong chemical in the wrong vat, it could be destructive, explosive. So very important there. Tire production has been another one that we've been very involved with, bobbin detection and verification. Yeah, so like I said, the imagination is your limitation here as far as what you can actually do with RFID. Do you have any other thoughts or questions?
RFID is great when barcodes won't work, right? So in a lot of cases, a barcode is just not going to stand up like the hoses, right? Or bins, right? They wear out, they peel off. So RFID, you can embed that in whatever you need to track. Like especially totes, I think that's an easy one where you have lots of work in progress, and you need to track that through the system. Or in some cases, like you had on the automotive, it's on the sled that the car rides on, so you know where that particular car is in production. And these are things I especially like the ability to go, you know, from have a read head talk directly to the cloud versus to the PLC, because in many cases you'll have a read head for the PLC, and it needs to know that information to be able to do, should this car go into production or should it go into storage? What are we doing with it right now? But also sometimes you want to have that information in the cloud, and you don't want to connect your cloud directly to your field bus because you don't want anybody hacking into your PLC. So having the ability to have a read head do IO link, maybe MQTT, and go to the cloud, that gives you that second pathway to read only data that nobody's going to be able to hack it, and shut down your process. So I really like that. I do have a question though. Looking at your product line, right? Do you find that most of your read heads are also write heads? The head that reads the data off of the tag can also write the data to the tag?
Yeah, for the most part, yes. I mean, some of our high frequency and low frequency heads are read only, but in this day and age, the overwhelming majority are both read and write.
Now, do you have a slide that shows your different products? Because I know that you have some really small, innovative products. I mean, I think we're all used to seeing the very large products, but if you could kind of take us through this picture here and talk about some of the different products you guys offer, because maybe starting with some of the newer products that you guys have, because I know you've been doing a lot with IO-Link and form factors and whatnot.
So these three here are our IO-Link offering as it sits today. There will be a slightly bigger one coming in this kind of package here. So roughly speaking, this is an 18 millimeter barrel sensor right here.
Yeah.
Um, Everybody's familiar with those from an 18 millimeter inductive prox.
Yep.
This one is sort of that access control panel um, reader that I
All
showed on.
rectangular. Yeah.
Yeah, so it's small and rectangular. It's maybe 5 millimeters thick, so it can go on a control panel and
Yep.
use a chip like this.
So those look like key rings for the audio
Yeah,
audience. Some
yep.
of them look like
So
key rings, washers, little square tags.
right, right. So um, again, that guy resides very, very well on a control panel, small, out of the way. Pop a hole in the control panel, run the wires in that, and then again you can set access restriction. Those, of course, it'll log when it saw the tag. So really, really good there. The next unit here is, we call it our flat pack. It is
Mhm.
roughly 4 inches by 4 inches by an inch and a half. Again, also on the IO-Link platform. So these will go straight into your IO-Link master, and it will communicate via IO-Link to your PLC through the IO-Link master.
Now, would I program these over IO-Link?
You can, you
Okay.
can, you so that's the beauty of the IO-Link protocol, is that you can do those types of things.
Okay.
Another one of our newest products is, this is our handheld unit, right? So not
All right.
everything has to be fixed. Um, so all of these other readers, they're intended to be fixed
Fixed
somewhere,
mounted. Yeah.
off a piece of 80/20 or whatever, and sort
Mhm.
of monitoring the system. But that doesn't necessarily need to be the case. Again, and what's nice about this handheld unit is, I'd say it's modular, but the top here is the actual read head portion, and that
Okay.
can snap off, and so you can have a low frequency, high frequency, and ultra high frequency use the same body. You just switch out the head.
Is that about the
Should you
size of a
have?
cell phone?
Yes, it's. I'd say it's closer to an iPhone 13 than anything else, but yeah, it's definitely the size of a cell phone.
Okay.
From the screen perspective, the head here is a little bit bigger,
Okay.
but
Yep.
in general, it's the size of a cell
So
phone.
that white area, that's a screen. That would have information on it.
Yeah, so that's a touchscreen. Yep,
Oh, all right. So
yep,
it's like a little tablet touchscreen with a read head on it.
correct, exactly.
So this would be good for somebody who maybe they're in the warehouse and they got to find something, so they can walk around and read the tag, and they'll display with the information right on the screen. Is that kind of an application for this? Would you see that, or what would be a ideal application for it? The portable reader.
So that's one, and in fact, it has a tag locating tool, so it could sort of. I don't know if you remember playing Hot Cold as a kid, but
I was just thinking that. Yeah.
it emits a frequency, the handheld does. So as you get closer to the tag, it gets louder, right? So yeah, so if you're missing a tag or looking for something, that's one way to do it. Also, spot
Cool.
verification, right? So if you have a pallet full of boxes and you want to just check what that is, you just grab it, look at it. Okay, that's what that is, And so any kind of spot inspection would be great. Again, finding a lost asset is another great use for that. And And I say a pallet full of boxes with tags. Some of your major e-commerce retailers, people like Walmart and Amazon, they're approaching a requirement for the shipments they receive to have RFID capabilities on them. It's almost a requirement of their vendors, and I wouldn't be surprised within the next 24 months that that's actually finalized. So again, having this, you get a shipment in from Amazon, or Amazon receives a shipment from a supplier, and they may want to do a spot check before they induct it into their system. Yeah, I mean, that's a perfect application for that. This one here is about the size of the portfolio you may carry into a call, or the size of a legal pad, and like I said earlier, the size of these units also depend on the range, right? So obviously, this being the biggest head, it has the largest possibility of range. Now, the other variable to that is the size of the antenna inside of the tags. So those variables you have to kind of adjust to your application. But in this case here, this head is the largest and the most powerful head on the market. Being that it is a radio frequency, it is something that's governed by the FCC. And they allow us to broadcast a maximum of 4 watts of power. That's what the FCC says we can do, and that's what this one can do. These smaller ones, they do 1.25 watts. So up to 1.25, and this one can do up to 4 watts. You don't have to just broadcast 4 watts, but should you need that because of your application, it's there.
What about that one? It looks like a circle, like a ring.
So this one is a ring, and it was initially designed for bobbin detection on a tire machine, right? So the end of that bobbin threads into this ring, and what it does is it just verifies the material on the bobbin before it starts running, inside of that tire making process. But
now the bobbin, explain what a bobbin is to the people who might not be familiar with it.
So basically, it is a large metallic bar that has either nylon on it or something that's used, some kind of belting that's used inside of a tire. And so at the end of this bobbin is embedded an RFID tag, which is read by this reader, and it verifies that it's the right material before it starts spooling up and embedding this product inside the rubber.
Perfect.
But as far as that goes, if you need to pass any tag, say, I don't know, there's a possibility if you mounted this inside of a chute or something like that and had things going through it, or at sort of the end of any kind of metal bar that needs to plug into something, this would be a useful tool for that.
So what would you say, out of all those products, which ones would you say are the hottest today? Is it the IO-Link products, or what do you see? What do you getting the most calls on these days? Is it the big unit with the long distance? Is it the handheld? Is it a mix of them?
These guys here, the 1.25 watts into a controller. This controller here can monitor up to 4 read-write heads, right? So you can so you can sort of distribute those amongst your process. You have 4 of those being collected into one. We do have this package here, as well as a controller that can do either a single head or 2 head for control.
Okay. Do those controllers have IO on it? In other words, it reads a certain value, it turns on an output?
So you can either have that in a triggered state, which you'd use maybe a photo eye or some sort of impulse to trigger the RFID head, or most people just leave it in a constantly reading state, right? And so once it does see a tag go in, it will pass the data to to PLC to the edge gateway, wherever that goes, and it will just pass that information through.
So if I'm not using the IO-Link models, what are my field bus options? Is it like Profinet, Ethernet IP? What Ethernet, industrial Ethernets do you support?
So Ethernet IP, TCP IP, Profi. So those are the typical ones that we have. And if you'll notice these two M12s right here, they're network switches, right? So you can daisy chain these.
Oh, all right. So they have 2-port switches in them. Nice.
Yep. Mm-hmm. So yeah, and obviously, when you do buy a fixed system, about 8 times out of 10, you go ahead and get the handheld as well. Just either spot checking or, the initial chip writing process. It's done with the handheld.
You can do it at your desk, and set everything up, test it, make sure it works, and then try it out in the field. Yeah, that makes sense.
Absolutely.
Well, RC, was there anything else we wanted to cover? I appreciate you taking us through the product line because I know you guys had a number of products. Was there anything else we wanted to cover?
No, I appreciate your time. I really do. Like I said, now my contact information is on the screen. Should you have any questions or application that you want to discuss, you can certainly reach out to Shawn and you can get in touch with me, or my contact information is on the screen, and we'll get you sorted out. I really appreciate you letting me on the show, and can't wait to come back.
Well, I really appreciate you coming back on. I know we really had a good time learning all about the ultrasonic safety sensor that you talked about last time. So if anybody needs that, please check out that previous episode. But P&F just has a great product portfolio, and we just love having you on, and hope to have you on again maybe later in the year to talk about some more of your awesome products. But really, really just appreciate you coming on and bringing our audience up to speed. Really do. Thank you, RC.
Thanks, Shawn.
Well, I want to thank RC again for taking time out of his busy schedule to come back on the show and bring us up to speed on RFID. Now, if you enjoyed this episode, please consider giving us a like and a sub. And if you want to get in contact with me or follow me, you can do so over at automation.locals.com. You'll also find all of my very affordable PLC HMI and SCADA courses over at theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, peace.